Hi, everybody. I'm Victor, and this is Evan. We are both software engineers at Docker. And today we are going to talk about distributed application. So I'm pretty sure you all know Docker. Docker, it's a way to build, ship, and run your application using Linux containers. But today we are going to talk about applications that are on multiple containers and that are also running on multiple hosts. And a few months ago, we announced 3 projects to do that. So the first project we are going to talk about is Machine. So with Docker Machine, you can easily set up new machines in any cloud provider with Docker installed on it. Then we're going to talk about Swarm. Swarm allows you to take all those hosts and it will create a virtual host, so you will be able to deploy containers very easily on your entire cluster. And the last project is Docker Compose. Basically, it allows you to describe your application, your stack in a YAML file, and just to give that to Swarm, and it will allow you to deploy your multi-container application on your cluster in just a single command.
Hello. As Victor said, the first part is Docker Machine. Docker Machine was announced back in November. That was where the alpha was in DockerCon Europe. Today we have a beta available, and the 1.0 is scheduled to be released in June. So in DockerCon Europe, with the alpha, there were a few providers, EC2, DigitalOcean, and Microsoft Azure, which could do basic operations, create and remove. With the beta, we have more than 10 providers, including local from VirtualBox to remote cloud providers, with 12 open pull requests for more. Provisioning, we want to do Cloud.init for more operating system choices. That's where we're kind of going into the future. Right now with the beta, TLS is enabled by default and is actually the only way you can set up hosts right now. And we'll see some of this in the demo. We have basic Swarm integration as well to create a cluster. And coming soon is the machine server with the REST API. So if we can switch to the demo. So first what we'll do is Docker Machine create. We're going to pass it a driver for this local demo. What we're going to show is just a single local provider. It would be used very similar to a boot to Docker. If you're familiar with boot to Docker, it uses a VirtualBox virtual machine with the Docker engine configured, and then gives you a local working environment. Machine does the same thing. It's going to launch a virtual machine using the VirtualBox provider. We also have support for VMware Fusion, and there's a pull request for Parallels and also KVM. What this will do is it's spinning up the VirtualBox locally, configuring the Docker engine similar to how boot to Docker would do it with TLS, and then it's going to give me a Docker engine that I can work with via local dev. What Docker Machine will also do is give me the ability to set environment variables to configure the client. So we now have a machine. We can view this with Docker Machine ls. We have a local VM, which is the Docker Machine. And we can now set our Docker client to use the environment variables to connect up. So we use that with an im command. And now we can run the regular Docker commands, Docker PS. We can also do just run a simple container. So this shows just your normal workflow. I have a VirtualBox, a local VM that I can run. I have a Docker engine. I can do stuff just as normal. What we're going to do now is show what that looks like with Docker Machine to provision to multiple cloud providers. So just as before, we have a local VM. We're also going to show how we would start to form a Swarm cluster. So the first thing we do is we're going to create a token. Victor can go in depth in this, but Swarm has multiple back-end discovery mechanisms. We're going to use the one provided by Docker, which is the Docker Hub. So we will first need to create a token. So run docker run swarm create. This will pull a very small, the swarm container, which is a very small container, and generate a token at the end of it. So now we're going to create another machine, only this time we're going to use Rackspace. We're going to pass some flags that allow the tell machine that we actually want this, instead of to be a regular engine, we want it to be a swarm host. We're going to tell it the token to use and the discovery mechanism, and to be a swarm master. And it helps if I use the actual Docker machine command. So this will go, and using the Rackspace API, it's going to launch a virtual machine and the provider, and do very similar to what it did with the local, only this time it's going to be remote. It's going to also set up TLS. It's going to configure SSH keys so that it generates an SSH key local, and then it's going to use that when it launches so that it can have SSH back and forth. So I'm also going to launch a couple others. This time I'll use DigitalOcean. That's the same thing, Swarm, also with Swarm Discovery. And one thing to note is the Swarm integration with machine right now is really experimental. So just beware, we may change some of the UX around it. So this is very similar, doing the same thing. It's going to launch a droplet in DigitalOcean, so as well as generate an SSH key, and then configure the remote host. Now, one thing to notice, or to note, local providers like VirtualBox, VMware Fusion, they use the boot to Docker ISO. So the boot to Docker distribution is a very lightweight, based on Tiny Core Linux, that comes with Docker, and just provides a very rapid, quick boot so that you can do rapid development locally. With the remaining providers, such as the cloud providers we use right now, it's limited to Ubuntu, the LTS, but we, as I said before, we're looking to add better support through Cloud Init. So now we have, well, while we're waiting on the other nodes, we have one launched, which is the Swarm Master in Rackspace. So we'll go ahead and configure our client to talk to it. Very similar command. We launch it, or we configure it with the im command. And one thing that machine does right now, we're looking to add support for a broader depth, but Victor will go and talk a little more about swarm labels. But right now with Docker machine, we automatically add a swarm label with the provider. So if it's a local provider, it'll give that. If it's your Rackspace, it gives Rackspace, Amazon, and so on and so forth. So once these are all finished launching, we now have a Swarm cluster that we can work with, and I'll turn that over to Victor to talk more about Swarm.
Can we go back to the slides, please? Yeah, so let's talk a bit about Docker Swarm. It's a similar story as Docker Machine. Basically, we worked on the Swarm proof of concept back in October, and we presented the first really rough version, the first alpha, at our Global Hack Day in November. And then at DockerCon Europe, we actually presented the actual alpha, so with a few features. A few days ago, we released the beta, and we aim for Swarm Final, Swarm 1.0 around June this year. So at DockerCon, the Swarm Alpha had a few features. So Swarm had a basic scheduler, so you were able to schedule containers on your cluster based on resources like CPU or memory, or you were able to choose a strategy. So we had like bin packing or random strategies, and we also had constraints. So using the labels that Ivan showed you earlier, you were able to do like schedule me a container on a machine that is provider equal DigitalOcean, or on a machine that is provider equal Rackspace. In the beta, we have much more features. We have affinity and anti-affinity. So I will show all of that in the demo in a minute, but basically you can start a container and you can say, I want to start another container, but I don't want to end up on the same host because that doesn't make sense. Or we also have TLS, so now all communication between the nodes are encrypted. And we have pluggable discovery backend, and that's it. So, and for the integrations, so we are fully integrated with machine, as Ivan showed you. When you start a machine with Docker machine, it's already like inside a Swarm cluster. We are partially integrated with Compose. Swarm will, Ivan will show you in a minute. Also, we're integrating with Mesos. So as I said, Swarm comes with a default built-in scheduler to schedule containers and clusters that are like 100 or 200 nodes. But if you want to schedule containers at higher scale, Swarm will be integrated on Mesos. So you will be able to use Docker Swarm on your Mesos cluster. And in Swarm, it's a really easy to use. It's distributed via the Docker Hub, so it's a simple image. So Ivan just started 3 boxes, as you can see on the graph here. 2 are on Rackspace, and 1 is on DigitalOcean. And both of those machines have 2 gigabytes of RAM. And so as of today, if you don't have Swarm, it's really painful to start containers on those machines, because basically you have to take your CLI, you have to connect to the first machine, do a few Docker runs, so start containers. Then you have to take your CLI and point your CLI to another machine to do Docker runs, and so on and so on. And with Swarm, basically you have the Swarm manager that is managing your entire cluster, and you just take your CLI and you talk to Swarm, and Swarm will schedule containers for you. And the great thing with Swarm is we are using the same CLI as Docker, so if you already have some tools or some infrastructure that is relying on the Docker CLI or on the Docker API, it will work out of the box. Like if you're using, I don't know, Fig, for example, Fig will work on Swarm. So let's go back to the laptop, and I will show you a demo. Okay, so as I was saying, I'm just using the regular Docker CLI, so there is nothing new. If you know how to use Docker on your laptop, you will know how to use Swarm. The only difference is my Docker CLI is not talking to a Docker daemon, but it's talking to Swarm. So if I do a Docker info, you can see that my cluster has 3 nodes. You can see the IPs and the numbers of containers running and their sizes. So let's just do a very simple example. Let's start a container, and as you can see, it's the exact same command. So let's start a shell. So if I do that, I have a shell, but the thing is, this container, this shell, it's running on my cluster, and I don't even know how. And as you can see, it was as easy as just starting a container of your laptop. If I do a Docker PS, so it's a regular PS that you already know, but in the names column here, you can see that this container, this BusyBox container, is running on the DigitalOcean machine. Almost all the commands are implemented, so you can do Docker inspect, for example. Of this container, and it will work. You can do pretty much everything. So that was a really simple example. Now I will talk about resource management. So let me remove this container. Okay, so as I said, we have 3 machines, and they have both 2 gigabytes of RAM. So let's say I want to start an Nginx container, but I want to say to this container, you can only use 1 gigabyte of RAM. So I'm using the -m, the flag you would use on your laptop, but on my cluster. When I do this, Swarm schedules this container for me on a machine that has 1 gigabyte of RAM available. So in that case, it went to the Swarm master. If I run the same command again, it's also going to end up on the same machine. And it did not. Okay. So basically, it should have ended up on the same machine because we're using bin packing. So we try to put as much as container as possible on one machine. So we leave all the other machine available. If I want to start a 2 gig container, it's going to again on master, and if I try to okay, in that case it didn't work, but basically at some point Swarm should refuse to start containers because you don't, when your machines are full, Swarm knows it because Swarm knows the state of your entire cluster and will say, yeah, I can't start your container, you don't have any memory available, so you have to add more machines to your cluster or things like that. So now I will try to demo constraints. So let me remove those containers quickly. And the last one. Okay, to demo constraints, I will use the labels. So as you might remember, we have one machine that is labeled as provider equal digital ocean, and 2 machines that are labeled as provider equal rackspace. So what I can do is I can start, for example, a web container. I will name it web. It's an Nginx container, and I will say I want you to run on a rackspace machine. So I just do -e constraint column provider equal rackspace. And when I do that, if I do a Docker PS, so this container ended up on rackspace, and so if I start other web containers, like if I start 3 of them, as you can see, they were all on rackspace or on Swarm master, which is already in rackspace. We have other constraints like I can say, for example, I want my container to run on a machine which is not DigitalOcean. So again, the Web4 container should end up running on either Swarm master or Node rackspace. So this is for the constraints. We also have affinity. So again, let me clean up the cluster. So let's say you want to start on your cluster a Redis cluster. So you're going to start by your master, for example. So let's start a Redis master. We'll name it Redis master. So right now this Redis master is running on Node.rs. And let's say you want to start more Redis containers, you want to start the slaves, but you don't want your slaves to be next to your master because it doesn't make sense. If the host goes down, you lose your slaves and your master. So what you can do is just start one Redis container, and you can add an affinity. So it -e affinity, and you can say, I don't want to be in a container, next to a container that is named Redis something. So if you do that, this container should end up on another machine. So it went on Swarm master. And if I try to start a second slave, it ended up on the third node. So now I have my 3 machines cluster. Every machine has a Redis container. So if I try to start another Redis container, as I say here, I don't want to be on a machine which already has a Redis container. this command should fail. And yeah, it did indeed fail. So Swarm told you, yeah, I can't schedule your container because I don't have any machine that has this constraint available. So yeah, again, the main advantage of Swarm, it's using the same API, the same CLI. I can do pretty much everything I want. I could do Docker exec inside my Redis 1 container if I want. So yeah, we can do almost everything. You can pull, inspect, history, login, almost everything you want. And we have all the tools that you are using today with Docker will work, but instead of just applying to one machine, it will apply to your entire cluster. And that's what's really great with Swarm. So let me clean up the cluster, and then I will give the mic to Evan to talk about Compose. Okay.
Thanks.
Sure.
Would you switch back to the slides? Thanks. So Docker Compose. Docker Compose helps organize and kind of orchestrate the two together. So Docker Compose helps create isolated environments. So if you're working, it works really well with development or in a CI setup. It helps, kind of stand up the various containers, connect them together so that they can work. And it's easy to scale applications and services, which we'll see in the demo. So what we're going to show in the demo is you've seen Machine, which has provisioned Docker engines and multiple providers, which then gave it to Swarm, which Swarm can now put these all together under a single endpoint to help schedule containers across. And now we're going to demo Compose, which can take an application or a stack definition and use Swarm to push that out and scale that back and forth. So what we'll look at first is the Docker Compose YAML file. So if you're familiar with Fig, this looks very similar. Here we're defining two containers. One is web and one is Redis. So these are using the first one. The web is just a simple Python application which will connect up to a Redis host and then show a counter. The second is a Redis master, and as you can see in the environment, which is how you pass constraints, as Victor showed via the -e flag on the Docker CLI, in the Docker Compose YAML file, we specify the constraint, and we're saying here that we want the provider of Redis to run in DigitalOcean, and similarly, in the web definition, we're saying use the affinity to do not run this where there are existing web containers. So we'll use Docker Compose to launch this. So if we run Docker Compose up with the -d flag, that is going to create the two containers and put it off into the background. So if you do not pass the -d, it'll run them in the foreground and just give your logs to standard out so you can interact them, which works really well with dev. In this case, we're going to run them as daemons, and now we can use Docker Compose PS, similar to use Docker PS. We now can see the two containers. We have Redis running, which is running on the DigitalOcean host, which we can check that by using Docker Machine. So the DigitalOcean is that IP, 146.78. So it's the Redis server is running on DigitalOcean, and we've launched one web instance on another host. So as we said, Fig can also help scale apps and services. So, or Docker Compose, sorry. So we use Docker Compose scale command. We're going to tell it web equals 3. So we're using Compose to call out to Swarm and say, schedule me 3 web containers that will run across the cluster. So if you use Compose PS to check, we see these are all now running. We can use curl to connect. And we can see that there's 1, 2, 3, and it's connecting up, same with Redis. We can now scale this back down, which will remove it, the extra web containers, and if we check it again, curl the application and see that it's still using the same Redis. So if we use compose to scale, say web equals 4, we can see we get an error which says unable to find a node that satisfies. So it had launched up to 3, but since we're using the affinity to tell it to not run any container where the web doesn't already exist, Swarm is telling us I don't have a node to put that onto, so it's returning an error. And so we can see that. So we've gone shown from end to end how to provision machines with Docker Machine to give us Docker engines, which are TLS secured, and we then have put them into a cluster with Swarm and use Compose to push a definition of a stack or web application out to multiple machines and scale it back and forth.
Can we go back to the slide?
Sure.
No. Okay, so thank you very much. All those projects are open source, and so Swarm and Machine are quite young. Compose also, so yeah, feel free to drop by on GitHub to test the project and give us feedback and open issues. We are here to answer all your questions. And do you have questions for now? Yes?
Is there a service discovery component coming as well, or request routing?
So, do you want to answer this one about the service discovery?
Okay. Yeah. So the question was, is there a service discovery mechanism coming? I'm assuming you mean Swarm, for Swarm, or just in general?
Something to discover what you've deployed. Sorry, something to just discover what you've deployed in a more, I guess, uniform way.
You want to answer that?
Yeah. So, yeah, it will be coming right now. Right now, it's the same Docker API. Swarm using the same Docker API. So. In Docker, you have events. You have an event bus when you get every event that's going on your machine. With Swarm, you get the same event, but for your entire cluster. So if you listen to that event, you can say a new node was added to my cluster. This container was started on this node or on this IP and stuff like that. So you could build projects that are listening to this event and basically could like write an HA proxy configuration on things like that. Yeah, the community already started working on projects like this. I'm not sure it will come inside Swarm itself, but it's definitely possible. Yeah. Yeah.
Do you plan to have some sort of front end for this, like a web UI?
Can you speak a bit closer to me?
Do you plan to have some sort of front end, a web UI for Machine, Swarm, and Compose?
Yeah, I guess it's a long-term plan. At some point, we'll have a UI where you will be able to scale up and scale down your clusters. The UI so the UI will use Swarm and Machine and Compose all together, and yeah, we will have a UI, and yeah, it's in progress.
Yeah, it's in progress. Nothing announced yet, but.
Is there another part with around private Docker registries that if I have an image that I want to distribute in a timely manner, to sort of push it out to all of these hosts so that it's not retrieving at the time of being provisioned, you know what I mean? So each Docker engine has a copy of that image waiting for it.
So right now we have the basic thing is when you do a Docker pull against Swarm, it will pull this image on every node. So yeah, I'm guessing if you want to you have a cluster of X machine and you want to set up the environment, you can do a pull of those 3 machines and they will go everywhere. We are also planning in the future to have some sort of like init container. So we will be able to do you can do a Docker run of, I don't know, anything like Docker run of your logger container, for example. You will be able to specify, I want this container to every host. And if a new host come in your cluster, the container will be added automatically. So it will be like the super container that is on every machine. It's also in progress.
So on the compose side, can I deploy something like, say, I give a YAML compose and say deploy it. If it fails, can it unwind the whole thing?
So, yeah.
So the question was, can it redeploy the whole thing?
No, if I want to deploy and assume that I have 5 containers.
The mic
I
is
want
not.
to deploy
I
all
think
of
the
them,
mic is
or or yeah, atomic, or either it should succeed or it should completely clean up.
Oh, we're also talking about that a lot. So right now, Compose, it's client-side. So basically, it's doing multiple calls. We might have, at some point, Docker will be able to receive this group of containers, for example, take this YAML file and apply it on as one big thing. So yeah, it would be atomic. Either I can or I can't. Yeah, it's also in progress.
Yeah, right now if it fails, it just fails. Yeah.
Any other question?
Cool. Okay. Thank you very much.
Thank you.
Thank you, guys. Appreciate you guys coming to speak to us today.